Okay, today we're talking about arithmetic and geometric sequences. Sequence is just a fancy word for pattern. So just know when we talk about sequences, we're going to be looking for a pattern and how to define that. N tells us the position, and f of n tells us what the term is. So for example, if it says f of 3 equals 8, that means the third term in the sequence is 8. So that would be like, you may have, I don't know how, it doesn't matter how many numbers, but whatever the pattern is, the third number is 8. That's what that notation means. F of n minus 1, so that's all one thing that's going to be glued together. We're not distributing that or anything else, will always mean the previous term. The last two little definitions that you need to know, some of these you may have seen before and some you may have not. An explicit rule means you can just plug in to find any term. And a recursive rule requires the first term and you have to count up to get to future terms. Now you're going to see what I mean by that here in a minute, but I would maybe just write that down and then I'll show you the difference between the two. All right, so let's look at some sequences here. So notice the n up here at the top. This is just telling us the 0 term, 1, 2, 3, 4. All right, that's just counting for us. And then on the other side, same thing. So this would mean like the first term is 6. All right, so let's look at how this works. If we try to notice the pattern, we either need it to be doing the same thing every time. So if we try to use addition, this is adding something different every time, which means that's not the pattern I want to use. Okay, so we need to come up with a different pattern there. So instead of addition, you may notice that right here, if we go from one term to the next, this is multiplying by 2. Multiply by 2. All right, that is what makes this a geometric sequence. A geometric sequence, you are either going to multiply or divide by the same ratio every time, each time. All right, so this value right here is called the common ratio. All right, let's look at how, ratio, not ratio. Let's look at how the other one might be different. So in this other one, we're not multiplying by anything. Notice that you're subtracting 4 every single time. So on this second example, this is an example of arithmetic. And on this, the rule is that you're either adding, or the definition rather, you're adding or subtracting the same, we call it the common difference. So the same difference each time. And we can make a note in your notes that this right here is called the common difference. All right, so if we look at the recursive rule, remember your definition of recursive, you have to define where you're going to start, and then we're going to count up. So this is what I mean by that. The first thing that we have to do for recursive rules is say where we're starting. So in this sequence, they tell me that the 0 term is 3. So we literally just write that. The 0 term is 3. Okay, and even though this is going to look confusing, recursive rule is actually pretty simple. The rule is f of n, so that's like your next term, equals the previous term. Remember, previous is f of n minus 1. And then think about what are you doing every time? You're multiplying by 2. So it's f of n minus 1 times 2. That's all you have to do there. All right, similarly for the arithmetic sequence, we say with where we're going to start. So this one starts at the first term. So the first term is 29. And then we can say to find each term, we're going to take the previous term. And we are going to, this time we're subtract 4 every time. Okay, it looks complicated, but that is really simple. All you're doing is using the rule, talking about the previous term and the rule every single time. Explicit is a little bit different, and I'm actually going to start with the arithmetic this time. Explicit in arithmetic is like saying y equals mx plus b, where b is your starting point and m is what you're counting by. But remember remember mathematicians are weird and they start at 0. So you kind of have to count backwards to get to that. So this one would be f of n equals, each time it's changing by 4. So that's negative 4x plus, and to figure out this part, we've got to look back, all the way back up here at our sequence and think about what would have been the 0 term. Well, to do that, we're going to have to go backwards and add 4. If we add 4, we get 33. So here my rule would be negative 4, and that shouldn't be x, that should be negative 4n. So we can make that an n instead, negative 4n plus 33. All right, we'll talk about how to use that here in a minute. The explicit rule for geometric is very similar. It's going to look a little different though. So f of n equals, this time we're multiplying. So we're going to say where we're starting, which is at 3. And then we want to multiply by 2 over and over again. But when we multiply over and over and over again, remember that's exponents. So that means I want to use an exponent to say that. All right, because exponents are repeated multiplication. Okay, all I'm going to do is one more of each of those for you just so we can make sense of what's happening. All right, so we need to, remember, we need to figure out what's happening every single time, and it has to be the same pattern. So this one is adding the same thing every time. It's adding 3. Because it's addition, we know this is going to be arithmetic. Recursive was the easy one. So recursive, we have to define where we're going to start. So remember, recursive has 2 parts. Where we're going to start, and that's going to be that f of 0 equals 2. And then we want to say, to find each term, I take the previous term, f of n minus 1. That whole part right there means previous. I take the previous term, and think about what are you doing every time? You're adding 3. So I take the previous term, and I add 3. Done with recursive. All right. Now we want to do the explicit rule. And let me see if I can explain this one maybe a different way. Okay, so to find the new term, we had to define where we're going to start. So we're going to start at 2. I'm going to write this one a little bit backwards. And this time we are adding 3. But since we're doing this addition over and over and over again, that's going to be plus 3n. Because think about addition over and over and over again, it's just multiplication. That may not make sense to you, and we can help sort that part out tomorrow. All right, so there you go. That's all we had to do. Let's look at one that may be geometric. All right, so on this one, if we try to see what's happening, here each time we are multiplying by 5. You may not notice that at the very beginning, but you notice it as you get to the end of the table. So this is going to be geometric because it's multiplication. If we do the explicit, actually let's do the recursive first. The recursive is the easy one. So recursive, we have to figure out where we're starting. So we just say f of 1 equals 1 over 25. And then we say to find the next term, we use the previous term. So if you need to write in your notes that the first one means next, and this one means previous. So the next term is the previous term times 5, because we're multiplying by 5 every time. The explicit rule, we don't have to say where we're starting. We will say that in the equation. So in the explicit rule, it's f of n equals our starting point, which is 1 over 25. Oh, I lied to you. Remember, mathematicians have to start at 0, so we actually have to go back and figure out what's the 0 term, and that would be 1 over 125. I can help you with that if you need that part tomorrow. So where we're going to start, times, now we're multiplying by 5, but since we're doing that over and over and over again, my variable is an exponent, because we're multiplying over and over and over again. That's what exponents mean. Okay, I know that may have been a little bit confusing, but go back and rewatch what you need to, and we'll use this to do some more things tomorrow.